So right now we came to question number let me see. Yeah, it's question number 5. There's part A, but if for the question is not part of this year exam, so I'm not gonna cover it. I'm thinking of covering it another another video if I have enough time. I may explain in another video. Definitely, I'm not gonna explain in this video. Everyone gonna say, "Man, we want to study for the exam. We don't want those perpendicular lines and whatever those business between them." So I'm gonna skip question A. I will go into question B. Question B says that evaluate the line integral taken in anti-clockwise around circle C1 of this one with the center at the origin. This question, first when I saw it, it actually tricked me. And tricked me like really badly. Like it could have, if it was if it was an exam and I didn't pay attention, I could have lost 6 marks, which is a lot of marks. But how it goes like this. So it's -y divided by x squared. Those pens doesn't work, they make me sad. So x squared plus y squared, comma, x divided by x squared plus y squared dotted with dr. So there's -y and there's x. First thing came into my mind, cool, this is sorry for YouTube, so YouTube. This is so cool. It's a function. So it's a function and it's a closed circle. Let's take its curl. Let's take the curl and I cross it with this function. We say let's call this function f. And I found that the function that the curl times the function is equal to 0. And I say it's super cool. Why? Because it's a closed curve, then the curl of the closed curve equal to 0. So it's a conservative field. Therefore, the integral equal to 0. And I say, okay, everything is good, everything is perfect. I don't have to take the hint of this question. I'm just gonna solve it this way. But then I found out something. I found out actually you cannot do it this way. Why is that? Because let's go. I'm gonna review a little bit about the conservative field and the properties of the conservative field. What is a conservative field? And what is the properties of a conservative field? And so on. So a conservative field is a conservative if we take the function that we are integrating over and we call it f, and then this function we came and we took the curl of that function. So we have the function, we take the curl of that function, which is nabla cross that function, and we got that the answer is 0. And if someone doesn't know nabla, then nabla is just a factor. The factor nabla is just a factor of dx, which is the partial derivative with respect to x, and the partial derivative with respect to y. This is nabla. So we take the curl of this thing. So we multiply. We have this as the first factor. We take the cross product with the second factor. This is what's called the curl of the function, and we get the value of 0. But this is the first thing that must be satisfied. Then curl equal to 0. But there's a second criteria. The second criteria is it must be over a simple connected curve. In order to say that the curve, the line integral across this thing is equal to 0. However, in our case, it's not a simple connected curve, because if you put x equal to 0, if put x and y equal to 0, which means if we actually talking about the origin, the function is not defined there. So there's a hole in the origin, and we are integrating over this area. So this is the area, this is the x-axis, this is the y-axis, this is the x-axis, and this is the y-axis, and we are integrating over the circle. This is the circle, and in anti-clockwise direction. So this circle will define an area. This is the area inside the circle. It will define the area inside the circle, and inside the area inside the circle, there's a point called 0, 0, in which there's a hole, there's a singularity inside it. So we cannot say that this function is a conservative field over this region, and thus the closed line equal to 0. It's not, because there's this singularity. So how can we evaluate it? We evaluate it as any line integral. So they told you by setting x equal to cosine of theta and y equal to sine of theta, or otherwise evaluate the line integral. So it's like, don't be smart, to give you what you have to do, and you just have to evaluate the line integral. They told you x is equal to cosine of theta, and y is equal to sine of theta. You find out something, and the denominator will be x squared plus y squared, which is going to be equal to 1, and the other thing will be x squared plus y squared, which is again going to be equal to 1. That's cool so far. And dr will be equal to dx hat time I direction in the I direction, dy so dx in the I direction time dy in the j direction. Vx in this case will be equal to negative sine of theta d theta, and dy will be equal to cosine of theta d theta. And what can we do right now? So this is cosine of theta and this is sine of theta. We change the integral into a theta form. So we take the dot product. First thing, change the function. So this is x squared plus y squared be equal to 1. What's left is negative. What's left is sine of. It's negative from the question. Negative sine of theta cosine of theta dotted with negative sine of theta cosine of theta over the scalar multiple times d theta, and this thing under the closed circle or the closed area. We have sine of theta, and you have negative sine of theta times sine of theta. So this thing will be equal to so the integral will become, because it's a circle, the theta will vary from 0 to 2 pi. Sine of theta times sine of theta will be sine the square of theta plus cosine the square of theta, and this thing will be times d theta, and sine square plus cosine square equal to 1, and we evaluate one from 0 to 2 pi, so the overall answer will be equal to 2 pi radians. Radians. So this is the whole question. So the whole question is actually, if you follow the hint and be a good person, don't be like me, follow the hint, and that's all. So you see in d theta is dx in the I direction plus dy in j direction. This is the way I define dr. dx in this case will be equal to differentiate this thing with respect to theta, negative sine of theta d theta, and dy is cosine of theta d theta. And you already have, and then you substitute the value of f for x and y will be equal to the first factor will be negative sine of theta, and you have negative sine of theta will be sine square of theta, and cosine of cosine will be plus cosine square all times d theta, and you want to evaluate it between 0 to 2 pi. Sine square plus cosine square is 1. The evaluation between 0 to 2 pi of a function of 1 will be equal to 2 pi radian, and this is the solution for this question. It's worth 6 grades out of 6 marks. The second part C is consider the function, the value function. Cosine of x, cosine of y is cosine of phi minus sine of x, sine of phi. Show that f is a conservative field. If you want to show f is a conservative field, you have to show something. First thing you have to show is that with those questions, the good thing with those questions is actually there's not most of those questions is not. So this is a conservative field, and people just go and take the curl. That's correct. You go and take the curl, and you actually at the same time you have to know that it's a conservative field because the curl of this function equal to the curl of this function equal to 0, and at the same time because it's defined everywhere. So whatever the region was, it will be a simply connected region. So with the curl, this question is application of the curl. You have to show that the curl equal to 0. And of course, there's all the math, there's proof, but I'm not gonna go why the curl have to be equal to 0 if it's a conservative field. So it's cosine. The function that we want to take the curl of is cosine of x, cosine of phi, comma, negative sine of x, sine of y, and want to take the curl. They want to take the curl of this function. So this function differentiated. The second term was differentiated with respect to the x. So it would be negative cosine of x, so sine of y, and subtract. This thing will differentiate with respect to y. So cosine of phi will be equal to negative sine of phi. So negative times negative is positive. So this is sine of y times cosine of x, and this the whole thing is equal to 0 because there's something and there's the negative of that thing. So the whole thing is just 0. This just so that this thing is actually a conservative field. The second part of question, find the potential function just that the function is a derivative of the curl of the conservative field. So what does that? So if the function is a conservative function, it must have the potential function. So we only have to find the value of this function, the potential function. This is a theory. So the first component of the function, so in which that the function is, it's so good, you know, because it say the function is the gradient. This vector is the gradient of that function. So it's just application of differential equation. If someone studied the differential equation, or just solving stuff. So this thing will be equal to the derivative of the potential function with respect to x. It will be the first component, cosine of phi. So the potential function will be equal to, you integrate this thing with respect to x, so this thing will be equal to sine of x cosine of y plus some function in terms of y. Because a function in terms of y, once you differentiate it, will give us this thing, because in terms of y does not depend on x, so it will give us back into this thing, and the sign will be given derivative as cosine. And the second term is the derivative with respect to y. So the potential of the derivative of potential function with respect to y will be equal to negative sine of x sine of y, negative sine of x sine of y. Yep. So once we differentiate this thing with respect to y, so this is, assume this is the function, and they gave us from this part that the derivative from the second part of that thing. So the second part of f, which is the function dy, is this thing. So if we take this function and differentiate it with respect to y, it should also give us this thing. So this is the partial derivative with respect to y, and this is the potential function. If we differentiate the potential function, it should be distinct with respect to y, should be distinct by definition. So the potential function divided by dy is equal to negative sine of y sine of x plus f prime of y, because the derivative of cosine of y is negative sine of y and sine of x is a constant in terms of y, and any function is f prime of y. By comparing the terms, we see that f prime of y is equal to 0. So f of y is just a constant. By constant I mean it does not depend on x or y. So if we do want to find the potential function, this is the potential function, we can put f of y as 0, because any constant numbers, and we still get the same value. And hence the last part of the question, hence about the y is evaluate the line integral. So how can we evaluate it? That one from x 0 to pi over 4. So if you have a line integral of a conservative field, so it have a potential function. If you have so you just, if you want to integrate it, or if it's a conservative field, if it's a closed integral, then the integral will be equal to 0. If it's not, then it will be C2 of sum the function dot dr. We have the potential function. We evaluate it at endpoint. So we evaluate it at pi over 4, x equal to pi over 4, y equal to pi over 4, and 0, 0. So it's pi over 4 minus potential of the function at 0, 0. And this thing will be equal to the value of the line integral. So generally speaking, and to recap what happened to this thing, to the math part, the whole thing, you have a conservative starts from here, you have a conservative field. Why? Because the curl equal to 0. The curl, this is just a function. It's just a vector value function. First component is derivative with respect to x, second component is derivative with respect to y. And you take the cross product of this thing times the function. If the answer was 0, then it's a conservative field. If the answer wasn't 0, then it's not a conservative field. If it's a conservative field, then there must be a potential function. We find the potential function to be equal. To sine of x cosine of y. And the last thing, tell you evaluate in path C2 the transform to. So we have this function. You just evaluate it. So this is like having an antiderivative. Once we think about integration as a normal integration, like the 1D integration, you will have an antiderivative where you just put the final value and put the minus the initial value. This is the same thing. This is like an antiderivative where we just put the final value minus the initial value of the curve. So this is the solution for question number 5. What's left is one question, which is question 4. We'll go back to it right now in another video.